Welcome back everyone, how are you doing today? We have a great news starting this stream. Finally I managed to get the magnetic encoder working, the one that we've been having so many issues in the beginning. I think the problem with it was that everything was okay except for the controller. I've been using before, I think this one, which is, this one is 8 megahertz. I don't know if it's visible or not, probably not. Yeah, so somehow it didn't really work when I was uploading stuff from Arduino. Now when I changed to 60 megahertz, finally I was able to flash it. Everything seems to be working, and the good thing is that we have an reading from the encoder itself. So that is actually very good news. I wasn't expecting that. So finally we might be able to build our own encoder that will be super small or maybe super short. I didn't want it to be too thick. This one is just for testing, but like obviously we can make it smaller. Yeah, so I'm gonna show you how it works in a while. But then I remember that some time ago we were also looking at this one, which is the white one that I just showed you is AS5600. So this one is okay. It has a I2C bus. It's kind of easy to read. I'm hoping that today we can jump into QMK and try to read it from QMK. Shouldn't be that difficult, but you know, we see how it goes. But then I remembered we still have this one, which is MT6701. And this one is a little bit more sophisticated because it has a bunch of nice features. And of course it has I2C, it has a serial, but it also has like a quadrature. So technically, I think I should be able to show you on the datasheet. So what is good about it, I think I should have it in specs somewhere. Yeah, indeed. So we have a, oh come on, why is it so slow? So we have I2C, we have a serial. I think there is like PMW or PWM, whatever it's called. Yeah, PWM. But the thing that is more interesting to me is that it can output like something, yeah, over this one. So this looks more or less like a standard encoder. And I am hoping that maybe if we can get it to work, we can get away. We don't have to do any kind of programming, reading all those registers and stuff. Maybe we'll be able to just like figure out which way it's turning, just like a normal encoder. That would be very cool. It could save some time. Of course, we can change some specifics like the signal and like what's that even? I haven't even really looked into it. Yeah, but like what is interesting is this AB. Of course, Z is like when we do like full 360. So this signal doesn't really bother us because what we need is A and B and like clockwise and counterclockwise. Yeah, like this. So that would give us like a proper reading. And looking at it over here, so we can set up a mode. So the mode is set via this pin number 2. I think it even says somewhere what is what. Okay, so on this one we have this this version SOP, and the pin number 2 over here, this is the mode. So we can have either ABZ or I2C. I think this is serial. And if we take a look, so over here somewhere there was this schematic, yeah. So if you want to do ABZ, this has to be connect to the ground, and if you want to do I2C and so forth, this has to be connect to VCC, yeah, over here. So this is I2C interface, and this is pin number 2. So as you can see, it's VDD. So we need to check, like looking at this one, there is some kind of jumper over here. It says I2C, and now it's opened. So if I remember correctly, I wasn't able to find where I got this. I think there was a explanation what is what. Maybe we can browse through AliExpress for a short while. Maybe we can find something similar there. Well, I'm assuming like if I connect this, that will be I2C, and if I don't, then we have ABZ. I have something. I found this. This is a logic analyzer. This could help us, but of course it's using some mini USB, and I threw away all of the mini USB cables that I had. Huge mistake. So I just ordered one today, of course too late, so we won't be able to use this analyzer today. We will have to try to do it some other way to check if it even works or not. We still have a oscilloscope, so maybe this will help, or maybe not. Another cool feature from this is that there is one more pin. Where is it? Okay, where? Increment, this one, push button. So it's pin number 5. I think it's also. I think we also, yes. So we have it over here, push. So what this does, it's sensing some kind of movement with the magnet, and then it will report this as a push button. So like there is some like a time threshold. I think it was somewhere at the end of the data sheet. Oh yeah, over here, push button. So there are some like time requirements, but seems like we can get like a push button reading. That would be even better for us because we can save the trouble with adding a push button. Yeah, so it would be very cool to get this thing to work. So what I did before the stream, I was trying to print like a tiny holder for that. Of course, I didn't have enough time. I mean, it would be okay, just that these are a little bit too big. Okay, so these are like 2.9 right now, and I think the hole is a little bit smaller. It's a 2.5. So maybe we can do it like 1.2. I hope that will be enough to get them to print. It's the board thickness. 1.6. I hope that will be enough. Okay, let's send this to print. Okay, I just need to go take a look if the print bed is clean. I'll be right back. Okay, seems to be fine. So maybe in the meantime I can show you how does AS5600 works. So I have a piece of code partially helped by AI. It was easier this way to just get the skeleton, and then I added some magnet detection, and I also changed that because for AS5600 it's not a continuous data stream, because it will output from 0 to 4095 if I remember correctly, and then the register will flip over to 0. So for example, you can be turning right all the time, and at some point you will get a reading that you just turned the wrong way, and this will happen at the border when the register is flipping over. So I had to come up with some way how to get this changing signal, how to smoothen it out. Well, I did something, seems to be working okay. So this part wasn't done by AI, I did it myself. So maybe there is still a chance for me. Maybe hope, not a chance. There's still hope. I can still write something. Yeah, probably that is not the best way how to approach this kind of a problem. There could be some mathematical formula or whatever. Okay, let's see if it still works. It was okay just yesterday. I'm not quite sure if it will be visible on the... Okay, something changed. Okay, not much to see. Let's go PC maybe. Okay, keyboard is... Let's just lift it up like this. I'm not gonna bother with moving the keyboard. Yeah, so we have that. Maybe something like this is gonna work. Yeah, so I can rotate this thing, and the movement is actually the correct reading. So as you can see, movement is 1 because I keep rotating right. And there is this a row angle, so this one goes from 0 to 4095. So if I scroll all the way, yeah, so we can see it's 4033, and then it will be jumped to 0 over here. Yeah, so you can see that row angle dropped to 14 because the register just flipped. And okay, this direction is not really important. What is important is this movement. So we still have number 1, which means that we are still rotating in the same direction. So yeah, this seems to be working okay. Should be easy to implement in QMK. Yeah, so that is kind of cool. Even if you can't get the MT6701 to work, that is still a win for us. Of course, we're gonna have to do some more work with the push button, because this one doesn't recognize push buttons as far as I remember. Let's take a look. I think I have a datasheet somewhere. over here. Yeah, I don't think so. It's only in out SDACL. Yeah, this one, the steer is meant to change. So I think if we like pull it up, so then the values will be increasing if we rotate right, and if we pull it down, the values will be decreasing for the clockwise rotation, as far as I remember. Yeah, so this one doesn't have any kind of push button detection. So yeah, so we need to get the other one working. I'm gonna move this aside. I would like to check which leg is number 2. So then we will be able to figure out like what is this jumper over here. So I assume that right now it's in this mode where we will get like AZ reading. All right, let's take a look. Okay, so this is the edge. So now pin number 2 is over here. So that's the mode, right? Okay, so we have this edge. So this is number 2. To bring my trusty multimeter. Annoys me all the time with this beeping. Right, so if pin number 2 is grounded, then we have standard configuration, we have AZ. Okay, so ground, where is ground? Okay, one question is, okay, I don't think we have mode anywhere. Okay, this one is VCC. Let's take a look from here. Okay. Okay, so we have it. So good thing is that we have it pin out. So number 2 is over here. Okay, this one. Okay, the first one is what actually? Okay, power supply. Okay, okay, this makes sense. It's VCC. Okay, let's take a look. Which one is ground? I think the last one is ground. And ground is over here as well. Okay, let's see. Okay, so it's not grounded. I wonder. So it's not VCC. Okay, so that's the same. So it's not really attached anywhere. This makes me wonder. Most probably it won't work. Yeah, so I was right. So this I2C jumper this I2C jumper, so one path goes to, yeah, this one goes to pin number 2, and the other one goes to VCC. So if we short this, we should get the I2C. So okay, that's fine. But currently, this pin is not really, it's not grounded or anything like that. And this makes me wonder, like, if it's gonna work. It would be better if we just solder it to the ground. Okay, one more thing. Okay. Okay, so this one is analog digital output in the center. Over here is ground. Okay, these are connected together. Okay, so we can use either this ground. Okay, this is VCC, this is ground. I hope this will do the trick. How's the print? Okay, I think it finished already. I will be right back. I hope this will fit. Let's take a look. Okay, not so bad. Actually, the other way around. Of course, I forgot to change the size of the top. Kind of loose, but okay, that doesn't bother me much. Okay, so from here, what can we do about it? Let's take this one, disassemble it. Okay, so maybe we can start this one with just checking out this push button. So I assume when I add this magnet, so we should get some kind of a reading once this is close. Okay, so I'm gonna be needing, okay, ground, VCC, one ground for the oscilloscope. Okay, this should be enough. Okay, more or less, I guess that's it. So we have ground, we have VCC. Okay. And this ground is not really that good. Most probably nothing will happen, but I'm having some hopes. It would be nice if I power it up first. So that's the switch pin. Okay, yeah. It was very short. I think I saw something. Yeah. Or maybe it's just me. No, something is happening. Hmm. I'm trying to do a trigger, but doesn't seem to be triggering at all. But I think I saw something. Okay. Right. I think there is something happening. This is output B. I guess this is just noise right now. Yeah, but when I turn, there's the wave changes. Okay, so maybe there will be something we can do something about it. Okay, so makes me wonder. I think we had some kind of small program with just an encoder. Let's take a look. I think we're trying to get it to work a long time ago. So maybe we can just connect directly and see what happens. Let's take a look at this quick. Okay, there is something about it. Okay, those pins. So I think we have it like a standard. Okay, I'm not quite sure. Okay, encoder. Okay, encoder map. Okay, so we should be able to see A and B if we have any kind of a rotation. Alright, so let's take a look. D1 and D0, which inputs? Oh, this is 2040, so no. Okay, this one. This pin out. I think I should save this one instead. Pro micro pin out. Okay. All right. So looks like I am using I2C, D0 and D1. So 2 and 3. Okay, that is fine. I can live with that. So we can try to connect A and B to this and see what happens. Okay, so we need like 2 more wires to get this working. Okay, basically we can have one more wire and then we can test directly if this push button works on this thing. Okay. I think we should compile it first, although it's possible it's already compiled, but might be some kind of an old version. No, it's not compiled. Oh, that is not a problem. Okay, let's see. What did it send? Okay, Chordie. I can't remember changing anything in Chordie. Okay, QMK, what was it? Compile. It's quick, not mega, and I think it's default. Yeah, default. Okay, let's see if it even works. Okay. No errors? Can't be. Alright, so let's plug it in. And DFU mode, and what happens now? Okay. Do we have any kind of output? So I think something's broken. Okay, my keyboard just stopped working. Yeah, okay, so we have an output. It's gonna take a while, I suppose. Okay, so that is not good. Okay, so it looks like it's outputting all the time. I would like to try. Okay. I hope I won't kill the stream with that. Okay, that is... Look guys, it works. A, B, A, B. Well, I don't know if it's like shooting A and Bs or what is happening right now, But if I turn it, now I have B, A, B, A. So this kind of seems to suggest that like it does work like on standard. Yeah, don't mind this F14 because F14 is from a different controller, the one that is controlling the mics when I change places. So that is nothing related to this one. Okay, looks like this thing works. Okay, what can we do about it now? It would be nice if I could just take a look. I'm kind of... Okay, so no, nothing is happening right now. If I do, let's say, notepad. Yeah, okay, so I can type no problem. Let's take a look. Let's make it like this. Yeah, so this should prove that it really works. But it's so sensitive, like yeah, but like even yeah, it's so good. Wow. So while the magnet is in, it's okay, but if I remove it, yeah, okay, if I remove the magnet, it goes crazy. It will start like, okay. Yeah, but it's great, like we don't really have to do anything about it. Like you just plug and play. And it's so sensitive, like a tiny bit, and it's already sensing. Cool. Oh, that is great. Kind of unexpected, I must say. Okay, makes me wonder. Let's unplug it. Yeah, so my suspicion was correct. It does work like that. It does work like a normal encoder. The only issue is that if we remove the magnet, it's going crazy. Yeah, maybe there is some kind of a way to make it stop. Okay, I read through this a few times. I can't remember anything, any kind of a note how to prevent it from outputting. Maybe we can do some kind of a pull-up or something. Ah, you're right. What about the Z? Okay, maybe we can also try. Maybe we can also try this push button detection, right? So yeah, we can connect this thing. Okay. So push button is over here. So one more wire, and we see what happens. We're gonna need to change the firmware, I'm afraid, a little bit. Some kind of a direct connection for this pin. I think we can use the one below, number, what was it? Number 4. We need to check later what is the name. Okay. Okay, so we have the wiring done. Let me move this stuff to the side. Okay, so cool. I even have I have it even prepared. So D4 is already set up. Oh wow. This pin out. Yeah, so pin number 4 that I just chose is actually D4 over here. So if we jump here, so we have a direct pin D4. Okay, so in keymap, what is it actually? Okay, it's A. So this is kind of a misleading. Okay, so let's do it. Let's make it, let's say it's gonna be 1. Yeah, that should do it. And then A and B will be just the encoder. Okay, saved, send. All right, it's gonna compile. Okay, so I think I'm gonna put everything together. I don't want it to spam A and B's. Okay, this is auto flash, so should be good. Okay, okay, we have a flash. Cool. Yeah, so nothing is happening right now, like when the magnet is in. Okay. Well, maybe it would be better if I'm not quite sure if I should use Notepad or this. Okay, let's try with this one. I'm gonna slowly. Yeah, okay, so A and B is normal. Oops. I can't see anyone. Try Notepad. Okay. Oh, hello there. Is there number 1 anywhere? I can't see it. One more try. So far, nothing. Hey, what I'm doing? Oh, I'm building a keyboard, but before I can continue, I'm trying to find a way to get magnetic encoders to work. So today we are working with MT6701, which seems to be kinda working, kinda not working. And I got AS5700 working already. So yeah, now I'm trying to figure out, because we have this MT6701. It has this feature that it can detect something like a push button when the magnet is close over here. So okay, I can't really see that too well. Yeah, so like if we move the magnet like this, it should give us this kind of an output. So okay, there's a push threshold. Push time. Okay, so there's like more stuff to it. So this got full register. Push time out. Okay, what does it say? Input push button function for okay, measurement of the. Okay, so we have like, I know, like a half a second maybe to increase and decrease. So far we don't have any one. We have only A and B's. Well, maybe our device is not really but it's like so sensitive if like for rotation. It's actually quite good. Yeah, can't really get it to work. Yeah, I think the same principle. It's a whole sensor. Actually, this chip, it has like more. I think it has 4 or something like that inside the package. So it looks more or less like this. So that's the chip. So it has an A and B output, which I'm testing right now. So I was looking at the schematic and it looks like this A and B behaves like a normal mechanical encoder, and yes, that is true, it does. So that's why we have this A and B outputs when I rotate. So that is like okay in a way. The issue here is that if I remove the magnet, it will just go crazy, which I don't really like, but like when the keyboard will be fully assembled, that shouldn't be an issue. But one more thing is that over here we have this push. So this should give us high when the magnet is kind of close. But so far I haven't been able to fit inside like this window, how they say I need to push. Most probably because it's not really well prepared. The window is kind of short, like looking at like a half a second. Maybe it would be better if I just try to makes me wonder if I remove this, would it be still okay? Because I don't want those A and B's, it's kind of spamming the whole thing. So it would be nice if it wasn't outputting anything for encoders, but like when we try to push, it would be nice to get the output then. Right, kind of lost. Okay, what should I do now? I should compile, right? And the window is gone. Okay, over here. Is it done? Okay, we have an error expected. What does it say? Okay, number 4. Okay, so we can't get around. Let me just move this out of the way. Okay, what can we do about this? Okay, how about if I go something like that? most probably it won't work as well. Oh, okay, it did compile. I wonder if it's gonna work. Okay, let's take a look. It's still plugged in. Where is the notepad? Closed already? Yep. Okay, so notepad. Okay, let's see what happens now. Okay, nothing is happening. Okay, at the same time, I don't really know if it's gonna work, like if the keyboard is even working. Maybe this is causing some kind of a problem. Okay, let's see. Okay, so assuming everything is on 0, right? Push threshold 44%. Okay, that's gonna be difficult to quantify, like how much is it? Okay, but this timeout is kind of weird. So does it mean that we need to hold it for like 8 seconds? And maybe I'm trying too fast. Yeah, 2 seconds. Okay, actually, yeah, let's push time out. So this part. Okay, so maybe this won't work for us. If I'm about to hold it for like 8 seconds, that is kind of... Yeah, and like we would like to have it... we'd like to make it work without any kind of I2C programming, right? So if we leave it on AZ output, I mean AB output, so we have no way to program this, and because it's a register, right? push threshold register. So there are like different registers over here. Z pulse, direction. Okay, registers, all the stuff, frequency. Well, okay, so it's an EEPROM. So technically, if we set it up once, it should remember. Oh, hey there, Desperate Lotus. I think it's been a while, right? Haven't seen you. Yeah, well, technically, I mean, ultra low profile. You mean which kind of a kick-up? I think the lowest will be choke. And other than that, I think what's there else, like the X switch. And I think I saw these, like, yeah, there were some like ultra low profile, but I forgot the name from Kale. The ones that you have to do like a surface soldering, right? I don't think this will work because Chordie needs very light keys. So the only keys that kind of work out of the box are chalk blue, because these are like 20 grams. And if you want to go with MX, then you can buy technically any key, I mean any switch. Yeah, any switch will work, but you have to swap the spring to 20 grams. I was thinking about, because Kyle has this, let's check. Kyle, and I think it's called X switch. But they have become like super expensive recently. That is not that much of an issue because Chordie needs like, I don't know, 8 or something like that, or 16 I mean. So maybe, yeah, these. So maybe it won't be that bad. Yeah, so 15 bucks per 7. What I think they're a little bit too, might be a little bit too heavy. I do have some somewhere. Yeah. Yeah, I was thinking about like something super ultra low profile. Yeah, but the requirement is that it has to be like a low force key, and these are not. What is the force? Yeah, 50 grams. So that is a little bit too much, especially if you need to press like 2 at the same time. So that might be difficult. But they have some different one. Okay, what is this one? Okay, cool. Yeah, definitely. Definitely not. These are some chalk ones. Yeah, I think I saw some of them on Reddit, but yeah, that will be difficult. So yeah, I think we are stuck with chalk. Like that's the easiest option. And then if you have access to MX springs, then you can buy 20 grams or something like that, and you can just swap the springs with some silent like. Otemu pitch are kind of okay. I tend to use them with swap springs, so these are kind of okay. All right, so totem. What is a totem? It's a keyboard. Let's see, totem keyboard. I think it's a keyboard. Ah, yeah, right. There's a GitHub for it. That's nice. PCB, build guide, firmware. Oh, these are chalk or not? Ah, yeah, chalk split. Yeah. Yeah, yes, it's just chalk. That is okay. Yeah, so the same type like totem. Delta Omega. Delta Omega keyboard. It's a keyboard. That okay, there are photos over here. Oh, so dark, can't see shit. Yeah, probably these are the ones. Hey, what's the name of this? Okay, PG1316. Oh yeah, exactly. Yeah, this one. I remember this one. This keyboard. What makes me wonder what is the weight? Oh, 35 grams. So maybe not that bad. Okay, 10 pack, 750. Oh, not that much expensive either. Might be even cheaper than the X switch from Kyle. But these, most probably they need some kind of an oven or something like that. I don't think you can treat them with hot air. They're gonna melt. And I don't have an oven, so it might be difficult to solder. SMD style, yeah. The practice board for that, very cool. Makes me wonder, is there like a datasheet from Kyle? Not much stuff about them. Yeah, okay, anyways, I kind of digress. Yeah, this might be cool, but it's at the same time very problematic to get to solder, so I think I will just stick with Chalk and MX. And going back to our stuff. Okay, what is the time over here? So, okay, one more thing. So after the boot, does it even say what are the values? Yeah. Doesn't say here. Well, I would assume that like all of them should be at 0, but like sometimes some registers might have some default value that is not 0. They don't mention which one is the default. So like, okay, but even if it's this push timeout, and I from what I understand, we need to hold it for like 2 seconds. So we push it down, so there'll be like a change in magnetic field. Then you have to hold it, let's say for like 2 seconds, and then release. So that will be registered as a push button, which is not what we would like. Let's see. Let's assume like the default 8 seconds, right? Okay, let's see what happens. Right, so there is nothing. No output. Nope, nothing. Nope. Guys, I think we can drop this idea. Yep. Okay. So this doesn't quite work for us. It makes me kind of wonder. Okay, so good thing is that it works without any kind of programming. So basically we have like two options right now. We can use either AS5600 or this one. And this one will work just like out of the box. Okay. So partial success, I would say. Okay, 5600. It makes me wonder if we should try to do some programming in QMK or just like move on. Where are we with Chordie? Alright, so we got infrared working. We have a different infrared right now. Okay, so the extensions, what do we have over here? Okay, I think we've done this one and the trackpad. Okay, we still need to do some stuff with all the canals. This is not done yet. Okay. Okay, the question is how big is this PCB? And we have two. Okay, I think I have a extension. Let's do this one. Okay, let's call it MT6701. And we already have, I think that's the size of the PCB, is it? Or at least these are the a little bit smaller than that. (22.6 by 22.6). Okay, so let's copy this thing. We are here. Remove that. We can make it smaller, right? That was 22.6 by 22.6. Okay. Okay, let's do cutouts first. So this I can remove. And remove this one. Okay, so this is roughly the PCB. I'm gonna steal the circle from this. That's the holder. Okay. It like this. Okay. Well, technically what we can do it the same way we had push button previously. So we can make something like this, if I can find it, of course. Yeah, we can have a switch over here, so that will be something that will be holding it, and then we can press the whole thing and just push it down. Okay, but we have plenty of space. Looking at it, maybe for now just a mock-up. I mean, just a mock. This. Okay, so on top of that, we're gonna be needing some bearing maybe, or how to rotate that. Okay, so for the choke, okay, so we have some, just like the top of the switch will be like somewhere over here. So we have some space left. All right. Okay, why is it like that? Why there's an open hole? Okay, because, okay, that's the opening from this. Okay, that is fine. We're gonna have to copy this as well. So this is how it would look like with this encoder. We can make the... So, okay, maybe we can change the name. Let's call it magnetic encoders. So we can make the first one... Okay, this will be PCBs. So we have to accommodate, because there'll be like 2 or 3, because AS56 has just like one size. So at least that's what I saw so far. Yeah, so this is 5600, so that's just like one PCB. But then for MT, we have 2 different PCBs. So one PCB for MT6701 is like this, it's kind of big. But there is one more. There is a smaller one that looks like this. It's quite a difference actually. But both should fit, no problem. Yeah. We can include the other one sometime later. Okay. Call it large, then we will have AS5600, and for this one I also have the PCB somewhere. Maybe not that much of a PCB, or maybe it's a PCB. Copy and paste it over here. What is the size from here to here? 905. Okay, that's a little bit odd. But we can do it like this. So okay, so it's the same size right now. Okay, let's take a look at those PCBs. Okay, I think I should move it over here. Oh, okay, so now we have a problem. This one doesn't fit. Or is it really this big? Hey there, I use 3D print. Okay, did you mean can I use 3D print? Yeah, sure. I think you should be able to print this somewhere. but it's not done yet. But yeah, once everything is released on my GitHub, no problem. You should be able to print everything because I'll be printing also myself. So yeah, should work no problem without any like fancy changes. So this one is, let's make it 23 by 23. Okay, so it fits. So 5600 fits, and the large MT also should fit. They're roughly the same size, more or less. The only difference is the mounting holes, that much. Okay. So let's say we would like to have the switch somewhere. Okay, so maybe with this one, maybe we can have the switch like underneath over here somewhere, because both of them they don't have any kind of a stuff below. Okay, the small one, so the small MT, it has some kind of a diode here sticking out. That might be an issue, maybe. If I have a switch somewhere, I don't. I don't think I will be able to find the back of switches. Or maybe. Okay, give me a sec, I'll be right back. Okay, got it. Take a look. For example, if you would like to have a switch like this. Yeah, this one is too short. Like if let's say if I want to have it in the center, so it's being blocked by the diode, so it won't be possible to push. But we can use maybe taller one. How about this one? There is a difference in height. Okay, this one is plenty. But at the same time, okay, I need to bring one more back. We have some other as well. So maybe this one will fit like right besides in the tweezers. Okay, which one was it? Okay, this one. Okay, this one fits. Yeah, we can fit this one in the center, and there will be still some space left. like this. And it's taller, so we can still push it. Yeah, this one fits perfectly. So we can reuse the same. I don't know if you can see that. Yeah, it's taller than the diode. Yeah, so we can use the same switch from horizontal encoder. Okay. Let's take a look. We have some kind of a mounting mechanism already, or some kind of a holder for that. Let's see if we can adapt it somehow. So these are like 3 parts. Okay, where are we? Over here. So let's make it switch holder over here. Okay. So this is much smaller, but that is fine. The okay, so I think we can get rid of this part. And okay, this one. Okay, let's remove it as well. So now we have just this. So let's put it in the center. Okay, so that is one thing. So if we keep it on the bottom, makes me wonder, for example, like it doesn't, I mean, it can't move right now, so it has to be some kind of fixed. So maybe, I don't know, like this to the side, and maybe we can like make it on the, if it was like touching the bottom plate would be holding it, but definitely we can't put it on the bottom plate at all, so it has to somehow be fixed over here. Well, maybe it would make more sense if we move it to the edge, like somewhere over here, because I was thinking that like if we grab let's say we have the knob, right? So it would be okay to push it maybe on top or in the center. I mean, center makes more sense, but on top would be easier to push. Because like right now, so the whole thing will just come down. And I think I can fix it somehow like this, because over here we need to have some canals like here and here. Well, CNC, I don't think it's possible to CNC that because you have those canals over here for the wire, so this won't work. Yeah, but 3D print, no problem. It's meant to be 3D printed. Technically, you could, if you have a CNC, you can mill like the bottom plate out of like aluminum or something like that. That would be nice, I suppose. Okay, one more thing, because I forgot, like, what was the distance from here? Remove the circle I'm making the panel. Not quite sure what you mean. Okay, so then there is an issue with the wires. Okay, so we need to like 0.7 from the bottom to here, so that we can still press and push the button at the same time. So we need also some kind of a mounting mechanism. This one is a little bit lower. Okay, so we need some kind of a holder for that. .6. This one was 1.2, so I'm gonna change that. It makes me wonder how it's gonna look like when we push this thing. So like if I make holders like this, so it's gonna be damn difficult to push, I suppose. But then, okay, we'll be pushing the whole thing. Makes me wonder how flexible this whole thing will be. So for example, if we do it something like this, 1.2. Okay, and let's do first slot. Well, I will make this one one handle, and then I can just copy them along the circle. And that doesn't look good. like copy and paste and move it around. Okay, not quite what I wanted. Maybe it would be better to have just like 2 from the bottom. Then it would be easier to press. Can't really make up my mind if I should just do it like this, diagonally, or maybe just use these 2 on the bottom. So then when we try to press it like this, this should like give us better motion than having it like that. This will kind of like fix it in place in a way. I think somewhere around here. Let's remove this. And I think I need to do this one. I project. Okay. See what happens now. It's upside down. Okay, not an issue. Okay, so let's say this will be like the mounting mechanism for that. So now if we take a look how the bottom gonna work. Okay, so it's something like this. So I think I can make it lower a little. Okay, so let's make this one up to this. Okay, so later on we can like put some holes here to attach the top to the bottom. Okay. So now the switch. What can we do about the switch? Okay. Okay, so one option is to just maybe go something like this, because this is the outer side. We won't be needing it that much, I suppose, because like the jack will be somewhere over here, and we can align it with the bottom. So then if the bottom plate comes in, it will support it, so we won't be able to press it. Like, I mean, it won't be flexing this much towards the bottom. How to do it? Okay, let's see. Let's go like this. Okay, and it vanished because we need to go not like this. Yeah, I think I need this plane. This one. Oh, perfect. Okay, so let's do it like this. This won't work. Maybe this one. Something like this, maybe. Like from here to here, and okay, this one. Let's see. Okay, something's wrong. Okay, forgot about one more thing, because I didn't close it. We have this, and this part. We need to close it from here. So if I add this one, it should be fine. Yeah. Is it? Yeah, it is. Okay, so this surface, let's move it to here. Pull it up to here. So then the bottom plate will come here as well, so it will fill this whole space. So when we'll be pressing from the top, this should stop it. Like it won't, the whole thing won't like flex together. So we should have like a good tactile feeling on the switch. And one more thing, okay. We can always turn it around, because I was thinking this diode is like sticking out. But okay, we can align it somehow. Okay, no problem. I can test that later. It would be nice to print this thing today. Just to have like a general understanding how it feels. Okay, so this one should be 1.9. Okay, so kind of Okay, so the holes over here. This is AS56, right? Okay, so the hole is actually bigger. I just miss. Okay, this one's quite big. Yeah, I can leave it like that, 1.9, 1.9. Okay, 2, so let's make it 3. Because this one is not 1.2 anymore, I'm afraid. 105. Hey, what is wrong with this? Damn it. I was supposed to thicken this wall. I think I forgot to include this. Now it should be okay. Nope. Okay, I can do it like this. I can just like double click those edges and just fill them with F. Yeah, perfect. So now we should have proper 1.2 millimeters. Yeah, 1.2 offset. Okay, that is great. Okay, so that is one thing. Okay, we don't need that. So the screw will come from the top or from the bottom, most probably from the top. Well, it doesn't really matter. From the bottom, from the top, as long as it holds. Okay, the question is... if I'll be pressing it, it might like come loose at the same time. Okay, we can worry about it later. Maybe we can add something from the bottom. Not important right now. Okay, I don't think I need those holes. Just to be able to print it. Okay. Okay, so can hide all of that. This one is empty. Okay, this. Okay, so we have only these two parts. Okay, so I think I'm gonna need this holes anyway. Hide the holder. Okay, that is kind of nice. I can just project these. This one, this one, this one. Okay. Hide this. Remove this one. Oh damn it! I forgot to enable the whole thing, because now when I will be pulling, it won't really work. Okay, like this maybe. It should go through all the layers. Yeah, perfect. This one is for holding the whole thing. Okay, I think these are the minus. Minus over here. I'm gonna make this as well. Okay, this is what? Okay, this one is 1.9. I think I made this a little bit too big. Let's make it 0.95. Just like this. Or should I make it larger? Okay, let's leave it like that. Let's see how it goes. Okay, so this will be kind of... Okay, let me just hide the PCB. Okay, so technically this will be like the bottom part of the whole mount, and then we will have a holder. It's kind of... Is it bound together? No. Ah, yeah. So the holder will be like this, and we can attach the PCB. The switch will go into the bottom thingy over here. So we can worry about how to get to the wires later. Maybe we can do like an opening over here, or maybe over here. Doesn't really matter at this point. Okay, so I think I will send it to the printer now, and we will work on it. Tomorrow is what? Is Wednesday, right? So yeah, we can pick it up tomorrow. Let's see how it turns out. We have plenty of stuff to do with Chordie. Yeah, I think that's it for today. Yep. All right. So we can finish this tomorrow. I will print it out. We can discuss the issues. It will be plenty, most probably. Or maybe I will just try to push it today. So tomorrow we can focus on some like more interesting stuff. And yeah. All right. Okay. Thanks guys for watching today. Thank you very much for chatting. Really nice having you here. And yeah, enjoy the rest of your day. Have plenty of rest and come back tomorrow for more work on Chordie. Thanks for watching and bye bye.